Now we discuss about the product for smart reliable network on chip. Next we discuss about the abstract for the product. Recently the trend of embedded system has been moving toward microprocessor system on a chip. In order to meet the requirement of real-time application, the complexity of SoCs to increasing the communication medium is becoming a major issue of MPSoC. Generally, integrating the network on chip into the SoC provides the effective means to interconnect the several processor elements or intellectual properties, processor, memory controller, or etc. The NOC medium features have high level modularity, flexibility, and throughput. The NOC compares the router of interconnect, allowing the communication between the processing element and other intellectual properties. The NOC relies the data packet exchange the path of router defined by the routing algorithm. Therefore, the path and the data packet allowed to take the network depends mainly on adaptiveness permitted by the routing algorithm technique. In this paper, we present a new network on chip that handles accurate the localization of faulty parts of the NOC architecture. The proposed NOC is to know the error detection mechanism suitable for dynamic NOCs, whether the number of positions of processor elements or faulty blocks vary during the runtime. Indeed, the very propose online detection of data packets and adaptive routing algorithm errors. Both presents the mechanism or localizing accuracy of position of faulty blocks. Our NOC architecture to describe the path analysis and fault analysis process mainly focused by our NOC architecture. The path analysis process, we apply the genetic algorithm technique to the NOC architecture. The fault analysis process to apply the checking conditions of data transferring process to the NOC architecture. Next, flow diagram for the product. The input data bits to transfer the routing process. The routing architecture is mainly for the four-way communication. Any type of source to apply the input and any place to destination for to allocate the routing process. The routing architecture with connectivity based on the mesh topology based connections. All the routers connected to the all router positions, and the genetic algorithm is to applied by the routing architecture designs. This the routing architecture designs to the applied the regular route wheel to allocate the parent node allocations. Then the parent node allocation to apply the child node allocation part to the next level. The next level to mutation and crossover functions. The crossover function to apply the child nodes, the different child node function to allocate the mutation function, and the fitness values to analyze each node functions and check the final known results for fitness functions. Thus the genetic algorithm fitness results to the previous and present results are applied to the genetic process. Thus the shortest path is allocated by the two allocation conditions. Then the genetic process to shortest path minimization to be occurred. Then the shortest path to be applied for the process. Then to analyze the fault analysis process for each locations, and to fault analysis condition to mainly based on the previous and present path data transferring technique, and to transfer the positions to check the fault analysis conditions, and to fault analyzing process to be mainly applied to the two transferring for the finally we run the output for the product. First of all, we run the Xilinx IC project. Then to select the routering function and to select the stack behavioring function. The stack functions to be mainly focused by the genetic algorithm process. The router function is separately to the router architecture results, and to process the how to process the router functions on source and destination location to find the NOC architecture. The genetic process architecture consists the regular route wheel functions then the crossover functions, and to the mutation process, then the fitness functions, and to finally allocate the fault allocation functions. These are developed by the behavioral language, then to select and simulate behavior model. The process is completed successfully, then to create the iSim project navigator. This is the simulation process. First, we apply the input for spin and reset clocking function for our genetic algorithm process. Then to set the spin 1, then the reset 1 positions, and the clock to initial 0 positions. Just run. Then to change the spin, reset, and the clocking positions. Then run. Then to activation clock is to be applied by the simulation results. Then apply, finally get the fitness output for the previous and present nodes. These are the shortest path analysis for our architecture. The fault enable function is 0 to the fault location is to find the 0 positions. Then the temporary storage data transferring nodes are to apply to the Z1 and B1 results. This is our the simulation result for our the NOC genetic processing results. Then implementation to select the route fitness function and to create the RTL schematic diagrammatic representation. This RTL diagrammatic representation is used to the what are the logical blocks presented in our SOC architecture. Then add and create schematic. This is the our logical blocks for our overall architecture functions. This is the logical structure to be placed by the architecture result functions. This is the technological diagram. This is the same process. The technology diagram is used to represent the what are the lookup table and how many wire connections, then how many flip-flop pairs in placed by the overall NOC architecture. Then go to the design summary process. Then select the synthesis report. The report is used to area and timing calculation for our NOC architecture. This is our the area calculation for our NOC architecture, slices LUT lookup table, then bounded input output function. Then the timing calculation for our NOC architecture. This is the minimum period of timing and the frequency, clock frequency. It's a directly proportional to the speed processing. Then the latency level to count of after and before clock functions. This is the timing and device utilization function is used for based on NOC architecture designs.